Today in Kafechi's Corner, we're going to look at real numbers and number operations along with algebraic expressions and models. So if we take a look at the first problem here, it says evaluate the expression for the given values of x and y. So what I did here is I substituted in, whenever I see x, I put a -3. Whenever I see a y, I put a -2. So if I take a look at -3 squared, remember that's +9, not -9. And I have 2 times -2 gives me -4 plus 1. So that gives me 9 over -3. So my final answer there is -3. Now looking at the next problem, it says write the numbers in increasing order. So that's lowest to the highest. So what we did is when we look at our original values, they're not all in the same form. So it's difficult to compare them. So the first thing we want to do is we want to put them in decimal form. So once I have those that need to be put in decimal form, then I can start with the lowest value, which happens to be -4.5. Now, when I list the next of them, like -4.5, -4 over 5 is -0.8, I don't leave it as -8. I always want to put it in the form that it's originally given to you. And I go from there. So again, here is the number line, and I plotted all the points again from left to right. They should match up in the order they appear on the number line. If you want to pause the video and take a closer look, you can certainly do that. All right, let's take a look at subsets of real numbers. So we have real numbers in this big box, and they break up into rational numbers and irrational numbers. So let's start with rational numbers first. If I start on the inside, my natural numbers, they're what we call counting numbers. I say to my students, if I asked you to count, you would naturally say 1, 2, 3, 4, 5, and keep going. They're all your natural numbers, your counting numbers. If I continue through those ovals, the next one is whole numbers. So that includes all the natural numbers, but it also includes 0. So it's 0 and all positive numbers. Again, no fractions or decimals. As I continue, we go next into integers. Now, integers are everything we've had so far, plus the negative values. Again, no fractions or decimals. So I like to say, if I asked you to create a number line, the integers is probably what you would draw. You would have 0, 1, 2, and keep going, and you'd have negative numbers, right? No fractions or decimals. They are your integers. Now, again, the bigger circle, again, includes everything we've done so far. It also includes decimals that repeat or terminate or end, okay? Anything that can be written as a fraction. So, for instance, 3 over 4, that's written as 7 over, that's written as 0.75. -3.4 is a decimal, but it terminates or ends. We are looking at this decimal here, 9.4544. That's just that keeps repeating in the same pattern. I have here 7 over 8. If I put that in decimal form, 7 divided 8 gives me 0.875. Now, if I look at irrational numbers, those numbers, they neither terminate or repeat. So if I'm looking, and again, they cannot be written as a fraction. So if I look at this value here, like we know pi, right? Pi is 3.14, and it keeps going on and on and on. It never ends. And it does not have a pattern to it. Same thing with square root of 2. It starts like this, and those numbers keep going with no pattern. They're considered irrational numbers. The next thing we're going to look at is properties of real numbers. You've done this before in previous classes, pre-algebra, algebra. So again, we're looking at properties that work for both addition and multiplication. They don't work for division. They don't work for subtraction. So for the first thing we're going to look at is commutative property, and that is simply switching the orders of the terms that we add and the order of the terms that we multiply. Now, the associative property, that's the one where I like to say, well, who do you hang out with? Who are you grouped with? Well, that is where the parentheses are. So in this first example, if I group A plus B first in parentheses when I'm adding, and then on the right-hand side, I group B plus C together, we're still going to get the same values. They're going to be equal. Same thing for multiplication. My grouping does not matter in using these operations. Now, the identity property, for addition, it's when I add 0. And again, doesn't matter if I add it first or second to a value, I'm going to get that value right back at me. Okay, same thing with multiplication. Does not matter where you multiply the -1 first or second, I'm going to get that same value right back. Now, inverse tends to mean opposite, so we have the opposite sign. So if A and negative A, for instance, it could be 6 and negative 6. Putting those together is going to give me 0. Again, doesn't matter the order which you add those. And for multiplication, if I have something like 7 and I multiply that by the inverse, or 1 over 7, if I take the reciprocal there, if I take A and I multiply by the reciprocal 1 over A, I'm going to get 1, right? Because this is going to cross off and I'm left with 1. Same thing if I multiply that fraction first. And the last one, distributive, we're very comfortable with. You've been doing this for a while. It means if I have something like, in this case, a monomial and a binomial, could be a trinomial or a longer a polynomial, and I multiply A times B and then A times C, that's what I'm going to get. Same thing, it does not matter if my monomial is second versus being first. I multiply those through all the terms, and that's what I'll get here. All right, let's take a look at some order of operations. Now, you know about PEMDAS. The P stands for parentheses or any grouping symbol. So that could be parentheses. It could be what we call brackets. It could also be absolute value symbols. They're also considered grouping symbols. From there, we move on and we have exponents or powers. And then we have multiplication and division from left to right. We do those at the same time. And the same thing, we do addition and subtraction at the same time. Again, moving left to right. Okay, let's look at an example. So our first example, I notice I have parentheses. So I'm going to bring everything down first. And I have negative 2 squared, again, gives me positive 4, not negative 4, because negative 2 times negative 2 is positive 4. And then I noticed that I took care of my parentheses and my exponents in that step. And now I have multiplication and division from left to right. So I've underlined those. So I'm going to bring down that 4. 5 times negative 3 gives me negative 15, plus 4 divided by 4 gives me 1. So now I just have addition and subtraction left to right. So 4 minus 15 gives me negative 11 plus 1. So my final value there is going to be negative 10. All right, let's take a look at the next one. Again, I do have a lot of parentheses or grouping symbols. So first, I know my absolute value of 6 is going to be 6. I'm going to rewrite that. And now I do have brackets and I do have parentheses. So I'm going to work inside out. So first, I'm going to just rewrite that 1 plus, there's my parentheses. And I notice that I have multiplication. So I have 7 minus 30. Okay, so again, I'm going to keep going. I have 6 minus 4 squared plus. This is going to give me 1. 7 minus 30 gives me negative 23. So from here, I have negative 4 squared. That's going to be minus 16, right? Because that's not in parentheses the negative 4. So I'm just squaring the 4. So I bring down this 6. And then I have plus 1 minus 23 is negative 22. So I don't even need that plus there. That's a minus 22. And I go to left to right. I have 6 minus 16 gives me negative 10. Minus 22 gives me negative 32. All right, now let's look at some combining like terms. So remember, like terms have the same variable raised to the same power. So in the first example I have here, 2x plus 3x, I can combine those because my variables are the same. They're both x, my letters are the same, and they're both to the first power. In my second example there, 2x plus 3y, they're both raised to the first power, but the variable or the letter are not the same. I can't combine them. And then in my last one here, I have 3x to the second plus 4x. Again, variables the same. They're both x's, but my powers are not, so I cannot combine those. All right, let's take a look at some examples. So I have simplified the expression. I'm going to start with the highest power, which in this problem looks like it's x squared. So I have x squared and y squared. I'll do that alphabetically. So x squared comes first. Then I have 4y squared and 9y squared. I can combine those, and that gives me plus 13y squared. Now I don't have any more y squared left, so no, or x squared, so I'm left with to the first power. So again, I'll go alphabetically. 2x minus 6x gives me negative 4x. And my last term there is plus 3y. All right, looking at the next problem, I'm going to do the same thing. Highest power looks like it's to the fourth power, so it gives me negative x to the fourth. Then it looks like my third power, I just have 1, so that's going to be 7y to the third. Now I have x squared and I have y squared, so I'm going to go alphabetically. Negative x squared, which is negative 1x squared, and x squared, which is positive 1x squared, they're going to zero out, right? Negative 1 plus 1 gives us 0. So that's already taken care of. And then I have 12, negative 12y to the second. And then again, my last power to the first is just this plus 6x. Okay, and looking at my last problem here, we're going to look at a word problem. You and a friend go to the coffee shop to pick up treats for a pool party. The muffins cost $2.75 and the croissants cost $3.10. Write an expression. Now remember, when we're talking about expression, we're not asking to solve for a value. We should not have an equal sign. So it says write an expression for this scenario. So it looks like the muffins cost us $2.75. You can use any variable you want. In this problem, it's not asking you to use a certain one. I'm going to use M for muffins, but you can use X and Y if you like. And then my croissants, I'm going to go $3.10. And again, I could have used Y there, but I'm just going to go with C for croissants. So that's my expression. Now in part B, it's asking you to evaluate. Remember, that means gives you a value, give you a number. So I have $2.75 for each muffin. And if I buy 4, I'm going to multiply that by 4. And I'm going to use addition because I'm also buying some croissants, which are $3.10. And in this particular problem, I'm buying 5. I can use my calculator for that, put all that in, and it looks like I'm spending $26.50 for 4 muffins and 5 croissants. All right, thanks so much for stopping by today. You have a great day.